Hey everybody, Brian here. 3 days ago I released Balls Out Physics episode 4, and I can't thank everyone enough for all of the positive comments and all the thumbs up. I mean, it's great. It really seems like this movement is starting to gain steam, and by movement I mean just questioning the world we live in. Questioning the model of the world we live in. I mean, in my opinion, we don't really have a complete model yet, and that's what we're all working towards. Using empirical data to develop one, if we can, and going from there. If you haven't watched that video yet, or you haven't watched the video, it's about the thermosphere and the second law of thermodynamics and the basic principle that hot energy, which is really kinetic, heat is really kinetic energy, and heat moves to cold. And in the comments, a couple of people mentioned Moonlight, and I'd seen some of this stuff, and I hadn't really spent too much time looking into it, but I've always thought it was very, very interesting. The idea that Moonlight is cool. There's some videos out there of people showing with thermometers or temperature, any type of temperature measuring device, that the temperature in direct moonlight, I'm assuming with the full moon, is a few degrees cooler than temperature in the shade of the moonlight. And a couple people brought this up in the comments, and that's so interesting. The cool moonlight, right? And or that moonlight is cool. And I think it was Anki or ENKI or Ank1 that was he posted a comment, or she, I'm not sure. I'm gonna say Ank. Posted a comment under my comment about the crappy video quality. I'm sorry about that, everybody. I'm still learning to use my new P900, which I love. But the comment in the comment, Ank said that you disagree with me. Ank disagrees with me about hot always flowing to cold because of the moonlight, and Ank stated that cold could flow to hot. And that's been in the back of my mind. I've been thinking about that because it does seem like light is coming from the moon, whether it's being reflected by the sun or whether the moon's emitting its own light. And so I was thinking about that yesterday, pulling into a parking place. I was on my lunch break and pulling into a parking place, and I remembered for some reason Eric Dubay saying that fire is intensified by direct moonlight, that fire gets more intense in direct moonlight. And I had thought about that when he said that, so that's really interesting. How could we test that? And I'd always thought about how you could do that with campfire. But then it hit me, that actually makes a lot of sense if moonlight is cool. Potential difference. To give you an example of this, my uncle up in New England is an avid cyclist. I mean, he rides all the time, and he rides in the middle of winter when it is freezing cold up there. And he was boiling his water and then putting it in his water bottle before he went out, and was always complaining that his water was freezing before he could drink it, because I mean, he's hardcore. He rides in much colder than freezing temperatures, and I realized, oh, it's the potential difference. If you take boiling water and put it in a freezer, and then you take the same volume of boiling water and put it in another freezer, an equal freezer, with the same amount of stuff in it, typically the boiling water will actually freeze faster than the room temperature water. You can look this up, because for some reason, I don't think we really have an answer for this. I did a little research on this, and there's some recent articles about this. When the potential difference, potential difference means the difference between temperatures is greater, heat starts accelerating faster and faster and faster to the colder area. So that's why hot water actually freezes faster to a certain extent. I mean, you also have to factor in time and how far apart the temperatures are and everything else, but the rate of acceleration is faster. So that would explain, if moonlight is cool, that would explain why fire is intensified, because the potential difference between the fire's temperature, which stays the same, and the surrounding temperature, which is cooled by the moonlight, is increased. And so I started texting Droid Fuel about this while I was eating lunch. We were going back and forth, and I'm sitting there. I'm thinking, for some reason I was centered around campfire and how I was thinking like how to move a burning log in and out of the moonlight, and I was like, how can we test this? How can we test this? He's like, just take a candle and move it in and out of the moonlight. I'm like, oh, duh. Yeah, that's all we need. All you really need is a candle. And so, first things first, we need to prove with experiments that moonlight is cool. But if moonlight is cool, my theory is that the light isn't shining from the moon. It's the moon absorbing heat from the earth, because hot goes to cold. I do believe that experimentation has shown it is the second law of thermodynamics. And so would that mean that the light we're seeing is not actually coming from the moon? We're seeing energy being absorbed from the earth, and it's glowing. It's like when you have a flashlight, or like a mag light, for example, which gives you a solid beam. When you shine it away from you, you can see the beam, the light's moving away from you, but what you're seeing is the light in the beam is reflecting off the air particles back at you. So the same thing could be happening with the moon. Just like you see that, like if you shine a light at a wall, you see the light imprint on the wall is being reflected back at you. Is that what we're seeing with the moon? It's actually moving away from us, but we can't tell because light moves so fast. It's really interesting. So, talking to Joyfield about this, Joyfield also mentioned that maybe this is why wolves hate the moon so much, because it's pulling energy away from us. Kind of funny. I thought it was hilarious, but I started thinking about how we can test this. You know, the candle experiment more and more, and I started looking at this last night. Right now, the moon is a super moon. We're in luck. It's a new moon, and on March 23rd, we're gonna have a full super moon. So here's what I'm proposing. If you wanna help out and record this, please do this. All we need are stick candles, and if you've got a thermometer or something to measure temperature to show that in a video too, please do. The more videos we get of this, the more experimentation, the more empirical data we can get, the more we can draw a conclusion about moonlight being cold. So here's my idea: is you get a pack of stick candles. You want them all to be the same. And the higher quality, the better, because typically you get what you pay for, and the more quality control. You know, every candle is going to vary a little bit from each other. And so you find a shaded area. I try to draw like a little porch roof here, and you put a candle there, light it. Put a candle out here, light it. I mean, it would actually be great to have two people and try to light them at the same time. You know, to light the one outside and the one inside, or I'm going to try to put 3 in the shade and 3 out in the moonlight. Okay, got the moon up here, and the theory is that the light from this candle will be a little bit more intense and brighter than the light from this candle. Now, chances are that it's going to be pretty hard to tell, because if it's only a few degrees difference, it's not. I don't think it's going to be this extreme. Now, obviously, this is not to scale. You know, I never draw anything to scale, but just have to make that claim that you're not going to see this much difference in the flame. So what I was thinking is, what we can do is let them burn for about half an hour, and then come back and measure how the distance from the bottom of the candlestick to the top, and see if there's a noticeable difference in how much this candle has burned down versus this one, because that's the way we can measure the intensity. I don't think it's going to be that obvious, but if these candles burned in the moonlight burn down noticeably faster than the ones that aren't in the moonlight, then that's a pretty good proof that fire is intensified. So now, the theory here, based on this, if moonlight is cool, I thought about this all day yesterday, and I started thinking, okay, the sun warms the earth. The sun transfers energy to the earth through heat. And if the moon absorbs heat, and this is a closed system, sun moves over the earth during the day, warms the earth, heats up everything, heats up the earth, the trees, asphalt, us, houses, all those things. Then the moon comes over and absorbs heat. It's always darkest and coldest before the dawn. Now, the moon isn't always over our heads all night long, but this is the general theory that I'm working on here. It's just an idea, a theory really. And so the moon comes by and absorbs the heat that the sun imposed on the earth. And so if this is a closed system that we live in, that would make a lot of sense. And so, based on Enk's comment, I started thinking, what if the moon acts like a capacitor for the sun? And so the moon just reabsorbs the energy from the sun, and it's a continuous 28-day loop. And is that what's actually causing the phases? What we're seeing in the phases is the capacitor charging and discharging. It's storing energy for the sun and then discharging it back to the sun over and over and over again. So the sun would actually be, the intensity of the sun would actually be increasing and decreasing with the phases of the moon. Now, I'm trying to think of ways we could test this further. First off, we need to really verify that Moonlight is cool. But it feels like Moonlight is cool. Just thinking about it on a full moon night, it seems cool. And I kept thinking, cool Moonlight. I was like, where have I heard those lyrics from? And you might notice I've quoted Whitesnake up here, the Still of the Night. It says, in the still of the night, in the cool moonlight, is some lyrics from, part of the lyrics from that song, and now I've had that song playing in my head constantly since I realized that. So this experiment and this theory has its own theme song already, which is great, and this is something we can easily test, and every month we can keep testing this over and over to get more results showing whether the moonlight is cool or not. Now, if you've ever looked into the electrical universe theory and the work of Wallace Thornhill, this man is a plasma physicist, PhD from Australia or New Zealand. I can never remember which country, but this guy, electric universe theory, is very interesting. There's a documentary called Thunderbolts of the Gods. I highly recommend watching it. It is based on the heliocentric model, but he's done experiments with plasma, basically showing that the craters we see on the moon were more likely caused by some kind of electrical storm. One of the main reasons is because the craters are perfect concentric circles on the moon. That doesn't make any sense that it would be all caused by collisions in space, because there's no ricochets or anything like that. Every object that hit the moon would have had to make a perfect perpendicular straight line impact right into the moon to cause those craters to look the way they do. And so he's shown through experimentation that this damage is electrical. So if it's a capacitor or something like that, and something happened in the past where it arced out on the Earth and there was a lightning storm or something like that, like Thunderbolts tends to theorize, is this what it could be? I know I'm speculating a lot, and it's I love speculating and thinking about what this world could be, and it is a wild theory, but I think it kind of works with the phases if it's charging and discharging. And I talked to Droid Fuel a lot about this, and he agrees that this could be, this is a valid theory. So it has to be proven, but I think we should really investigate this. So that's it. If you want to help, please get some stick candles. And March 23rd, we need a still night. I might not have a still night here in Florida, so as many people as we can, because we don't want the wind blowing our candles out, as many people are ready to do this, the more chances we have of success on the first try. And this is a supermoon, so this would be great. I would think that the supermoon would create more light, and then so the temperature differential will be greater. We'll see a more obvious result in how the candles burn down. And then thermometers. I'm looking into getting a device to actually measure the temperature of the moonlight, and also show the temperature difference wherever I am. So yeah, this is the idea. Just throwing this out there for discussion. Please comment. Let me know your thoughts on this, and we'll keep experimenting, trying to figure out what this world is, searching for truth. So until next time, peace.